Welcome back to Let's Code. I'm Chris Biscardi, and today we're talking about rendering strategies in Perseus. Perseus is a web framework built on top of Sycamore, which is most similar to a Next.js for a Solid.js in Rust. If you have no idea what those words mean, don't worry about it. Perseus is a client-side and server-side web framework that allows you to render in a variety of different ways that we're going to go over today. When it comes down to it, what Perseus calls rendering strategies effectively gives you two ways to render HTML, because that's what we're doing at the end of the day. We're rendering some HTML. All of the rendering that we do uses the same mechanism. It renders either in the browser, at build time, or on the server. Rendering in the browser, of course, is something that we're probably not going to modify since it needs to run in the browser at some point. The way that I would classify the rest of the rendering strategies is either static generation at build time or server-side rendering. Now, in practice, those two rendering strategies are effectively the same process. You take some data, you render it using Rust to HTML, and then you either have an HTML file or an HTTP response to give the user. On top of what you can consider a static rendering or a server-side rendering, we have the option to completely remove the server and build a static website that we can upload to a CDN. But on the other end, we have a number of different caching and revalidation strategies that we can use to determine when and if a certain page should be updated. With those caching strategies comes different ways of fetching the data that we need and generating the URLs that we want to render. So let's start with what they call build state. If you're unfamiliar with the way that Perseus defines templates, we can see here that we're creating a new template at what will effectively be the URL build state. We have a build state function, so all of these strategies are going to be part of the builder API when we're constructing our templates. And then we have the template itself. The template itself takes the page state that we've defined and turns that into some view or some HTML. This is the core of how we would render any page anyway, so it doesn't make much of a difference. Note that as we talk about this, the macros that we're using will change. So the state that we're getting in our template is named PageStateRx, which is the name we're giving the macro, not the struct PageState. Then we have this getBuildState function, where we are given a path and a locale, because Perseus has native support for internationalization. And our job from this function is to return some page state. Note that it's page state without the Rx on the end. So we're just returning the struct, which Perseus is responsible for changing into the Rx. This is an async function, so for some URL, we can make some request to either the file system or a database or something like that, and return that data in our page state for the given URL, which allows us to use that page state, again, in our template. So given some path, we fetch some data, we return that data, and then the template controls what we do with that data. In our case, we aren't actually using this path variable, but it becomes useful when we start mixing some of these strategies together. The next strategy that combines or can combine with the build state strategy is called build paths. We can see our template for build paths uses the build state function we saw before, as well as a template, and adds a build paths function, because we're going to use this template to build multiple different pages. Which pages is a question answered by the build paths function. Again, this is an async function, so we can do whatever we want here to figure out which URLs we want to render with this set of templates. In this case, all we have is a vec. So given that path comes into our build state function, which we saw in the last example. We make some request, we get some data, and then we have the page state, which gets passed to, eventually, the page itself. So we can fetch data for a specific page, and we can set up which URLs to render at build time, but those are both pretty static. There are other sources of state that we'll need, especially if we decide to server render anything at runtime. For this, there's request state. Request state will allow us to fetch any sort of HTTP cookie or something like that, anything that you would need that only exists at runtime, say after your user is logged in or something like that. Again, we set up our template, we define a request state function using the builder API, and we specify a template. Note that we aren't using build paths or build state, so this is going to run all the time at runtime. The function signature is very similar though. So we get request state with a path and a locale, but we also get the request. And the request is a normalized version of whatever web server API that you're using. So it would be a normalized version of like the Axum request or something like that. This function is again responsible for returning the set of state that we care about for this template. And we return that page state that we can then use to render our given template. So we've got data at build time, URLs at build time, data at runtime. Built on top of build state and build paths is what's called incremental generation. And what this does is call the build state while the server is running instead of at compile time. This is most easily understood as lazy static generation. So where we might use build state and build paths to statically generate our blog or something like that, or our marketing pages, we may have so many pages that we don't want to incur that cost at build time. This is often a problem if you're doing, say, a lot of work for each page, or because there doesn't seem to be any concept of batching these requests together to your database, you can end up making too many requests at a given time during your build if you use build state. Because if you have 100 pages, you'll make 100 requests to your database. If you have 1,000 pages, it'll be 1,000 requests to your database. If you have 1,000,000 pages or something like that, well, you see how this kind of just scales with the number of pages at the very least. So a solution to that is actually kicking the generation of the page off until somebody actually tries to request that page from the server. And that's what incremental generation is. You build the page on demand, and then it's there to be served as a static asset, waiting for the next request. So if we look at the template setup, we can see how this is built on top of build paths and build state, because we've got the build paths and the build state functions that we worked with earlier, and then we call incremental generation. We also, of course, need our template because otherwise we can't render anything. So again, get build paths will return us the list of URLs that we want to render. Then for each of those paths, we can call get build state and get whatever we want, or say, hey, this is a URL that we don't want to handle. Again, each template is responsible for itself and any URL under it. And the more specific a template is, the more likely it is to win when compared to other template functions for the same URL. On top of that, we just get the page state again, and we can render our view. So we've got render at build time, render statically on the server, render at runtime on the server, and the final piece to pull it all together is how do we deal with caching and determining when we actually need to re-render these pages? Because the content can update in the database, at which point we probably want to re-render those pages. And the answer to that is revalidation. Revalidation gives us two additional builder functions. One tells us that the page can be re-rendered every 5 seconds, so it will revalidate every 5 seconds. We also have a function that's called should revalidate function that will run on every request to determine whether this page should be re-rendered. And this is built on top of the build state, the build paths, and the incremental generation. So to put everything together, we can generate a set of URLs, we can get the state for each of those URLs, and we can render it. The page will revalidate every 5 seconds, and in this case, it will revalidate on every request as well. So this is the way that you can get these URLs that you're trying to render to update on the server. It's important to note that because in the example we used the time-based and the request-based validation, that the request-based validation only runs at least every 5 seconds, not on every request. If you don't set the time, then it will run on every request. And finally, if we've got build state and build paths, and we've got runtime state or request state, we can also combine those state methods. So state amalgamation is a way to use build state and request state in the same render path. So for this new template, we've got the build state, which we've covered, and the request state, which we've also covered. And we've got a new function called amalgamate states fn. And of course, we've got our template right at the end. Our build state function runs and maybe happens in the build process, for example. And then our request state runs and happens on the running server. Note that both of these return the same state, so it returns a page state in both cases. Our amalgamate states function is responsible for merging those two states. So we've got the build state here, which is a page state, and we've got the rec state here, which is also a page state. And we can determine which thing we want here. In this case, they get combined into a format, so it's build says whatever, server says whatever. But you could imagine this being used to combine user state, such as like an HTTP cookie or something like that, with some build state. So if you have a bunch of blog posts, but you want to be able to show whether a user is logged in or not when you render on the server. And then we've got our page state and our template that uses it. And that's it for combining states. It's just a matter of taking one state and another state and defining how they merge together. So that's it for rendering strategies. If you only use build state, for example, you can, instead of running a server, export to files and upload to a CDN with Perseus export. Now, there's quite a bit involved in all of these rendering strategies. But one thing that I noticed that does not seem to be supported anyway, or at least I couldn't find it mentioned in the documentation, is, for example, turning off the client-side render or restricting the JavaScript only to application pages or something like that, which to me is another rendering strategy. There is support for hydration, but it is also noted that hydration could potentially cause issues, so I don't know how stable that is necessarily. Now, that doesn't mean you can't render client-side, it just means that it will re-render your entire application rather than just hydrating what it needs to. But as I hope you can see now, rendering strategies are based on when you render your HTML, when you fetch your data, and how long you're going to cache it, or when you're going to revalidate that caching. You could mentally model this as Perseus as a static site generator that determines when to re-render those static pages. In that way, it's kind of an advanced static site generator that can do things at runtime in the same way that you do them at build time. But I also see that it doesn't natively support things like batching requests to your database. So you may want to do that with a build.rs or something like that, where you can fetch a bunch of data from the database. If you've got the database file locally, then you can develop off that instead of making a ton of requests to whatever your database of choice is, overwhelming your MySQL or Postgres database, for example. This is one of the problems that Next.js has as well, where you can end up just throwing absurd amounts of requests at your database if you are generating a large amount of pages. There are other systems that do request amalgamation effectively, but it doesn't seem like Perseus is one of those, or at least it doesn't have native support for that. Still, it is nice that you can choose to statically render, server-side render, and have native support for revalidation strategies. When I first saw the amalgamation state, I thought it was going to be an accumulation of cached data on your server. So as things changed in the database, you could use change data capture and make that data get sent to your server, which would then update ahead of time any pages that needed to be edited or invalidate the pages that would need to be updated. And I'm sure you could write this support in, but it would have to be additional code in addition to Perseus. It is not built into the framework. Still, I think that Perseus is so far the route that I would take if I was going to build a real world application, which I'm considering doing. It does seem to be, at the very least, the most well documented server-side rendering framework that supports the kind of rendering strategies that we talked about today, which is super interesting. So I hope you enjoyed the video, and if you have any questions, leave them in the comments, and I'll see you in the next video. Have a great day.